Okay, what we are doing here is that we're measuring the noise figure and gain on an AirSpy 70 centimeter preamplifier. This has the 4 MHz SAW filter installed, and I'm in N8ZM's RF lab, and I'll go ahead and turn this over to Tom and let him explain what we're looking at.
Okay, again, the upper trace, why don't you go back to the screen?
You bet.
You don't need to see me. The upper trace is noise figure, the lower trace is gain. And what you're seeing in the pass band of the amplifier is that the noise figure is running just below a dB, and the gain is up around 18, which is on the lower trace. Now the markers on the lower trace are set up. The first marker is pretty much the center of the pass band. The marker to the left, which is labeled 2 delta 1, is basically set at the 3 dB down point from marker 1. The marker 3 is set up as a delta to marker 2. So the idea was we dialed that into where it read essentially 0 dB difference from marker 2. That means it's also 3 dB down from marker 1. And if you see in the upper left corner of the lower display, you see that the frequency difference between marker 2 and marker 3 is almost 8 megahertz, and the difference in amplitude is about 1/4 of a dB or less. So that says they're pretty much on the same level. Now, because of resolution as far as the number of points, why there's a little bit of quantization error there, but you get the general idea. If we were to do it with a network analyzer and a lot of points, why it'd be more accurate, but this gets the point across. Now what you're seeing off to the sides, the spikes and where the noise figure goes up, is the SAW filter is really pretty sharp. And so the noise figure measurement has a lot of trouble dealing with the fact that it's trying to measure gain and noise figure at the same time. And it occasionally gets into situations that come close to being divided by 0. And so you get these funny looking spikes. Anyway, that's basically it.